Okay, this is lesson AMU1L5, and we're going to talk about imaginary numbers. Now, first for the vocabulary. The imaginary unit I was defined, and it is defined that I equals square root of -1. So an imaginary number was not found, it was created. Okay, as a definition, what it does is it helps us solve a problem that we're going to look at in just a minute. Now, a pure imaginary number is BI, and where B is real and I is imaginary. So what kind of a problem could you have that you needed to solve with an imaginary number? Well, let's have a look at that. Let's just look at these two numbers, square root of 49 and square root of -49. And you all know that the square root of 49 is 7 because 7 times 7 equals that root, 49. All right. But what about -49? What would be the square root of -49? It can't be 7 times 7 because that's not -49. It also can't be -7 times -7 because that makes +49. And it also can't be -7 times 7 because by definition for a square root, you have to multiply the number times itself. They have to both be the same. And -7 is not the same as 7. So having a negative under the radical was the problem, and the imaginary number was the solution. And this is how it solves that problem. So here's our first three problems: square root of -144, square root of -80, and square root of -36/121. Now, before imaginary numbers, you just didn't have an answer for this, but now you can use this manipulation technique, which is what it is. All right, if the square root of -1 is equal to I, let's see what happens if I could rewrite this as the square root of -1 times the square root of 144, because a negative times a positive would give me the negative back. All right, now I know that the square root of 144 is 12, takes care of that. Now I have a definition for this. I can get rid of the radical. Square root of 1 is I. So using imaginary numbers, I can write an answer. But that lets you know, if you see an answer that has an I in it, what happened to cause that? Somewhere along the line, you had a negative under a radical. So it kind of symbolizes what happened before. All right, let's look at 80. Same thing. I can rewrite this as the square root of -1 times the square root of 80. So this will become an I. All right, how could I break this down? Into what's the largest perfect square that will go into 80? 16 times 5. All right, the square root of 16 is 4, so now I have 4I square root of 5. All right, once again up here, since it's a negative under here, I'm going to pull out a -1 times, now I have +36/121. I can convert this using my definition to an I, and then the square root of 36 is 6, the square root of 121 is 11, and you normally want to put your I behind your whole number, okay? Now let's take this concept of the imaginary I and let's expand it out to more powers. And usually you just memorize the first four. I to the first power is defined as square root of -1. You must memorize that, which is just I. All right, -1 is I. Square root of -1 is I. All right, what if I have I squared? Well, if I is square root of -1 and I square it, what happens? The radical and the exponent cancel each other out. So I squared equals -1, following the definition. All right, what about I to the third? What you're going to do as your exponents get larger is you're going to break them down. Remember, when you multiply bases that have exponents, what do? You add the exponents. So as you are breaking these down, you are subtracting the exponents. So I to the third could be rewritten as I to the second times I. Well, what was I to the second? -1. I is just I. So I could multiply those together and get -I. Then I to the fourth, you could rewrite this as I to the second to the second. You're multiplying exponents here. So that would be -1 squared, which turns to +1. So that is how they develop the first 4 powers of I. And the rest of them are just iterations of that. So how would I rewrite I to the fifth? Pull out I to the fourth first, because that's +1. You always want to take that out first and then deal with what's left over. So I would rewrite this as I to the fourth times I. Now your I to the fourth is just a 1, so we don't have to worry about it. And I, its definition is just I, so we're going to leave it like it is. All right, I to the sixth, I could rewrite as I to the fourth times I to the second. All right, I to the fourth was +1. And what was I to the second? -1. So simplified form of I to the sixth is just -1. All right, let's do I to the seventh. Once again, we're going to go with I to the fourth times. Now, I to the third is okay. What is I to the fourth? It's just +1. And what is I to the third? Well, it was -I. 1 times -I is -I. And now the last one, what is I to the eighth? Well, it's going to be I to the fourth squared. I to the fourth is 1, and 1 squared is 1. And I promise this is all going to make more sense once we start doing problems. You'll see how we pull those out. So let's look at some pure imaginary numbers, and let's work number 4. Okay, let's look at number 4, I to the 11th power, and I have my powers of I written over here. So what you want to do is just start breaking down that exponent, pulling out all the multiples of 4 first. Why? Because a multiple of 4 is a +1, and it just, in multiplication, it just kind of disappears. It's your invisible number. So that's what we want first. What is the largest multiple of 4 that will go into 11? That would be 8. So I'm going to rewrite this as I to the 8th times I to the, what's 11 minus 8? 3. All right. Now, every multiple of 4 is +1. So this is actually +1 times +1, which is +1, and I don't need it anymore. All right, what is I to the third? Come over here on your chart and look. That's -I, so that's what you put. All right, let's look at number 5. Number 5 says -3I to the 21st. And once again, we're going to break this down. What is the largest multiple of 4 that will go into 21? Now I'm just going to have the -3 out here. I'll take care of it later, times. All right, I to the 20th, right? Because 4 times 5 is equal to 20. And then what does that leave me left over? Just an I. All right, I to the 20th is +1, so I don't need it anymore. And I'm just going to have -3I. I can't do anything to the I because that's the base definition. So that will just have to stay there. Okay, for number 6, we have 6I to the 13th times 18I to the 3rd. So let's combine these first. 6 times 18 is 108. And when I multiply I to the 13th times I to the 3rd, I'm just going to add exponents. So that gives me I to the 16th, which makes it really nice because 16 is a multiple of 4. So it's just 1 times 1 times 1 times 1, which is 1. So simplified answer here is 108. Number 7 is 2I to the 9th to the 5th. Now when you have an exponent outside, everything in here gets that exponent. So we have 2 to the 5th, I to the, all right, 9 times 5 is 45. All right, 2 to the 5th power just gives us 32. Now let's start breaking this down. What is the next power of 4 under 45? What multiple of 4 will go into 45? 44, and then what do you have left over? Just an I. Since all of these are 4s, they're all positive 1s multiplied together, so what you have here is 32i. Okay, number 8 is negative I squared to the 5th times negative 3i to the 10th to the 3rd. So first of all, let's take care of this one. What is I squared? Well, I squared was negative 1. So what is negative of negative 1? Or negative times negative 1? Positive 1. Positive 1 to the 5th is 1, and multiplication times 1 is just going to render this. So now we can come over here and start taking care of this. Negative 3 to the 3rd power times I to the 30th power. Everything got a 3. So negative 3 to the 3rd power, 3 times 3 is 9, times 3 is 27. Since this is odd, it's going to stay negative. All right, I to the 30th. What is the next multiple of 4 that will go into 30 without going over? Well, 28. So we're going to have I to the 28th times I squared. All right, I to the 28th is positive 1 because that's a multiple of 4. So what I have now is negative 27. And what's I squared? Negative 1. So you wind up with positive 27 for a final answer. Okay, number 9 is a little more complex, and I'll tell you there are several really good ways to work this. So if you work it a different way but you get the right answer and you keep your chart in mind, you're not, you're using your powers, then you're good to go. All right, so first of all, the square root of negative 9 cubed. Well, let's find the square root of negative 9 first. Let's go inside. What is the square root of negative 9? That's going to be 3i. How did I get that? Well, remember, the square root of 9 was 3, so that wasn't a problem. What I actually did in my head is I broke this up into 9 times negative 1. Now, what was negative 1? I squared. So I had 9 times I squared under the radical. So the square root of 9 was 3, and the square root of I squared was I. And that is raised to the 3rd power. So 3 to the 3rd power is 27, I to the 3rd. Now since I have another I over here, I'm just going to leave it in I format for right now. And let's see what we do here. All right, 2 to the 6th power is 64. And I've got I to the 6th. So when I multiply 27 times 64, you get 1,728 I to the 9th power. Okay, so at least we have it in one term. Let's break it down again. What is the largest multiple of 4 that'll go into 9? 8. So I can break this up into I to the 8th times I. Now remember, that's going to be positive 1. So my final answer here is going to be 1,728 I. And yes, there are other ways you could have broken it down. So if you got the right answer and you use your chart, you're good to go. So now let's look at complex numbers that take the form a plus bi. An example of a complex number is 5 plus 3i. All right, on number 10, we have 6 minus 4i plus negative 8 plus 6i. And you add these just like you've been adding your variable expressions. If the variable part or the imaginary part matches, then you add the coefficient. So here I'm going to add 6 plus negative 8, which is negative 2, and minus 4 plus 6 would give me plus 2i, and that's it. Okay, here's number 11. We got negative 3 plus 5i minus 4 plus 6i. Now, this one, you're distributing what's in front of these sets of parentheses. This one is positive, so nothing changes here, but on this one you have to distribute the minus sign. So that's going to give you 4 minus 6i. Other than that, it's just straightforward. Minus 3 minus 4 gives you minus 7. and plus 5 minus 6i is going to give you minus I. You don't have to put the 1, okay? Okay, number 12, I need to distribute this 4i into this set of parentheses. So 4i times negative 8 is going to be negative 32i. All right, 4i times 5i is going to give me 20, what? I squared. Now, I can't do anything with this, but what is I squared? Well, that's negative 1. So now you have negative 20 minus 32i. And standard form is where the I part is on the end. So go ahead and change that to negative 20 minus 32i. And number 13 here, we've got 6 times 3 plus 2i minus I times 5 minus 7i. So we're going to distribute this one, and then we're going to distribute this one, and then we'll clean up whatever we can. 6 times 3 is 18, and 6 times positive 2 is going to be positive 12i. All right, now over here we're distributing a negative I, so watch your sign. I times 5 is just going to be 5i, but negative I times negative 7i is going to be positive 7i squared. All right, these two I can combine. So now I have 18 plus 12 minus 5 is 7i plus 7i squared. All right, what is this I squared? Let's do 18 plus 7i. Well, that I squared is negative 1. 7 times negative 1 is negative 7. So 18 minus 7 gives you 11 plus 7i. Okay, let's take a look at number 14. We have binomial times binomial, so we're going to FOIL it or distribute it, whichever way you want to term it. 5 times 9 is 45. And 5 times negative 8i is negative 40i. All right, 3i times 9 is positive 27i. And 3i times negative 8i is negative 24i squared. So let's combine what we can. 45 we'll take care of in a minute. Now, negative 40 plus 27 is going to give you a minus 13i. Now, I squared is negative 1. So when you multiply 24 times negative 1, you get negative 24, but minus a negative 24 changes to plus 24. And let's simplify. Combine 45 plus 24 gives you 69 minus 13i. That's it. Okay, let's look at number 15. Now I want to call your attention to something here, because this is actually one of the most useful things about imaginary numbers. If you will notice, 5 plus 3i and 5 minus 3i, what are these? Do you remember this word? Conjugates. So I want you to pay attention to what happens when you multiply conjugates that have an imaginary number together. In fact, what I want you to do is I want you to try this one first and see what you get, and then I'll work it next. So if you want to pause the video, put your answer down, and let's see how you do. Okay, so what we have here is two binomials multiplied together. We're going to FOIL them together or distribute it. So I've got 5 times 5 is 25, and 5 times negative 3i is 15i. All right, here I'm going to have positive 15i, and then I'm going to have a negative 9i squared. So minus 15i plus 15i cancels out totally. I squared is negative 1, remember? So what I actually have here, and negative 9 times negative 1 is what? Positive 9. All right, 25 times 9 plus 9 gives me 34. So conclude this as a tool that you can use. When you multiply conjugates of imaginary numbers, you actually get rid of the imaginary number totally. That's pretty useful. So now let's try number 16. We have 3 minus 11i all squared. Now remember, when you square a binomial, you don't just square each term in the binomial, you have to expand it out. So this is what we have. Now we're ready to FOIL. You've done this before. The only thing different is we're going to be looking to see what happens with those i's. All right, 3 times 3 is 9. This will be negative 33i. And this one is negative 33i. And then when you multiply the last two together, negative times negative is positive, 121i squared. Okay, combining terms here in the middle gives you negative 66i. All right, what is this negative I squared? This I squared. It's negative 1. So 121 times negative 1 just makes it negative again. All right, 9 minus 121 is going to give you negative 112 minus 66i. Now let's look at number 17. We're just going to go through this. Order of operations tells you to do this multiplication first, and then we'll distribute over here. Now with these two binomials, we are FOIL methoding or distributing. So 6 times 7 is 42, and 7 times minus I is minus 7i. Negative 2i times 6 is going to be negative 12i. And then negative 2i times negative I is going to be positive 2i squared. Okay, down here, distributing a positive 3 is going to give you 27. And then 3 times 5i is going to be negative 15i. So let's clean it up and combine what we can. First of all, 42 minus, all right, 7i minus 12i gives you minus 19i. All right, this I squared is a negative 1, so let's go ahead and multiply it times that 2, gives us negative 2. And then plus 27 and minus 15i, we'll carry it on down. All right, 42 minus 2 is 40, and then plus 27 gives you 67, so that takes care of all those. Now, minus 19i and minus 15i gives you minus 34i. Number 18 is 6 over 7i. So you might be looking at that thinking, what am I supposed to do? Okay, an I, as we remember, refers to or correlates to a square root of negative 1. You don't want square roots in your denominator. That's irrational. So what we're going to do here is we're going to rationalize the denominator. You don't want i's in your denominator any more than you want square roots. So how do we do that? Well, same way as we rationalize with square roots. We're going to multiply the top and the bottom by I. This is a tool for your toolbox now. If you need to get rid of an I in the denominator, just multiply by I over I. Remember, anything over itself is 1. So you can do this mathematically. It's justified. Multiply across the top is 6i. All right, 7i times I is 7i squared. Now what's I squared? Negative 1. So what you actually have now is 6i over negative 7. And we would just write that, put your negative out front. So now let's look at number 19. We have 26 plus 4i over 8i. Once again, what's the problem here? That we have an I in the denominator, so we need to rationalize it. Okay, you go ahead and give this one a try before you watch me work it. All right, I'll give you a second. You can hit pause. So now let's look at number 19. We see in this problem we have an I in the denominator, and like we just talked about in the last problem, that is a problem. So I want you to give this one a shot. You're going to rationalize that denominator with the I. So you go ahead and give this one a shot, pause your video, and then you can hit play again and see if you got the right answer. So to rationalize this denominator, I'm going to multiply it by I. And then to balance that, I'm going to multiply times I on the numerator. And when I multiply through, that's going to give me 26i plus, all right, I times 4i will give me 4i squared. All right, up here, I'm going to have 8i squared. Now remember, the I squareds can convert to negative 1. So this is negative 1, and this is negative 1. Let's see what that's going to give me. 26i is not affected. All right, 4 times negative 1 is negative 4, and 8 times negative 1 is negative 8. So that's looking good now. All right, all your fractions you need to be in simplest form, and most of the ones we've done beforehand have just been in lowest terms. But this one, there's a common factor between all three of these. So let's get that out. Factor the greatest common factor out of your top. That's going to give you 2 times 13i minus 2, and then you still have the negative 8 down here. Okay, so for our final version, the negative can come out front. All right, 8 and 2 reduce down to a 4. And then I still have 13i minus 2 up here, but usually you want to put your whole number in front of your imaginary number. And then last but not least, because you have a negative and a negative, let's go ahead and distribute that. And that's going to give you 2 minus 13i over 4. A lot of little things in this one. Okay, number 20, we've got I over 2 minus 6i. So obviously the I in the denominator is our problem here. We need to rationalize that. Now, this is a little bit different because we have a binomial difference. But if you'll remember back in number 14, glance back up there, we saw a coincidence there. What happens when you multiply a binomial difference with an imaginary number times its conjugate? Well, it eliminates the I, doesn't it? So now we're going to use that coincidence as a tool. I'm going to multiply this bottom by its conjugate. And whatever you do to the bottom, you just have to do to the top. So now let's distribute. I have 2i plus 6i squared on the top. Now when I multiply these, let's see what's going to happen. 2 times 2 is 4. And 2 times 6i is positive 12i. This will give you negative 12i. And this will give you negative 36i squared. And cleaning that up before I bring it over here, these two things cancel out. This is negative 1, and negative 36 times negative 1 changes to positive 36, and 4 plus 36 is 40. All right, now this was also a negative 1, so let's clean it up some more. And 6 times negative 1 was negative 6, so now I have 2i minus 6 over 40. And once again, you notice that 2 will go into all three of these terms, so we can reduce. I'm going to factor 2 out of this and get I minus 3 over 40. All right, the 2 will go into 40 with 20, so now I have I minus 3 in my numerator over 2. And as a best practice, we want to rewrite that numerator with the I at the end. So that's going to be your final answer there. Okay, number 21, we have negative 5 plus 5i over 1 minus 3i. We see the I in the denominator. That's the difficulty. So since it is a binomial difference, or a binomial with an imaginary number, the way we're going to fix that is to multiply by the conjugate. Now if it's just a single monomial term with an I, you can just multiply by I. But if it's a binomial or more, you're going to have to multiply by the conjugate. All right. So on the top here, I have binomial times binomial, so I'm going to FOIL it. Negative 5 times 1 is negative 5. And that's going to be minus 15i. And then plus 5i and plus 15i squared. All right, and then under here, when I FOIL it, I'm going to get 1. 1 times 1 is 1. And plus 3i. And then these two is going to be minus 3i and minus 9i squared. All right, let's clean it up. This is negative 1. So when I multiply these two, now I have minus 15 here. All right. Minus 5 and minus 15 gives you negative 20 up here in the front. Now minus 15 and plus 5 gives you minus 10i. All right, let's straighten up the bottom now. Plus 3i minus 3i cancel out, which is what we intended to do. That was the whole purpose of what we did. I squared is -1. -9 times -1 is +9 now. And 1 plus 9 is 10. Okay? And once again, we need to reduce. 10 will go into both of these. So we can factor out a greatest common factor and then reduce, or we can do it right here since it goes into both of these. All right, 10 will go into 20 and leave me 2. 10 will go into 10 and just leave me 1. So now I have -2 minus I. Final answer. Okay, so we're working into our last section here, which is operations with negative radicals. And when we look at problem 22, square root of -15 times square root of -5. Before we work this, I want you to recall when we worked with radicals before, we had a rule that said if your indexes match, say square root of 2 times square root of 3, then you could multiply what was under the radical. Well, if you look at this problem, you're probably thinking, hey, that solves the problem. Because when I multiply a negative times a negative, I get a positive, and then I can just simplify it. However, one thing about those laws of radicals is, and they don't usually mention it in big letters, but those rules are only valid for positive radicands. So right off the bat, we can't do anything with this until we get rid of the negative, and that's where our imaginary I is going to come in. So what I'm going to do with this to get rid of the negative, first of all, is I'm going to do 15 times -1. And then over here, I'm going to do 5 times -1. All right, what is -1? Well, recall your powers of I. -1 is equal to I squared. So what this is 15i squared. And what this is 5i squared. All right. Now, what's the square root of I squared? Well, it's just I. So now we have I square root of 15. Square root of I squared is I square root of 5. All right, now what we're able to do is multiply the two radicands together. We can also multiply these two numbers outside, the i's. So now what we have is I squared onto the square root of 15 times 5 is 75. Now let's clean this up a little bit. What is I squared? -1 again. We're going back. All right, when I look at 75, what's a perfect square that will go into 75? 25 times 3. So when I pull take the square root of 25 out, that's going to give me -1 times 5. The 3 is left under there, so clean it up. -1 times 5 is -5, square root of 3, final answer. And there are a ton of steps here that you could have done in your head and left out. I just wanted to progress it, explicitly so that I don't lose anybody. Okay? Let's move on to the next one. Now let's look at number 23. 2 times the square root of -10 times -3 times square root of 2. So what I want you to do is pause the video and you use the techniques that we've been over so far and see if you can come up with the answer, and then hit play again and see if you got the right one. Okay, so let's see what I would have done. First of all, to get rid of that negative under here, I'm just going to make this 2i. We're cutting out some steps now. This would have been 10 times I squared, and then the square root of that would have been I, so let's just jump that a little bit. All right, same thing here. To get this to a +2, I'm going to make it times I squared, and then I'm going to pull the square root out. So this is -3i square root of 2. Now that we have positive numbers underneath the radical, we can multiply those together. We can multiply the numbers outside the radical together, and that's going to give us -6i squared square root of 20. All right, let's clean it up. I squared is -1. -6 times -1 is positive 6. Now let's simplify 20. What is a perfect square that'll go into 20? Well, we can break that down into 4 times 5. The square root of 4 is 2. When we pull that out and multiply it times the 6, I'm going to wind up with 12 square root of 5. Okay, let's look at number 24. And the first thing I'm going to do is convert all of my negative radicands into positive radicands by, if this is a negative square root of 2, I can change that to I times positive square root of 2. All right, same thing with the negative 6. I'm going to bring the I out, and that's going to become positive 6. And 18 is already positive, so that's fine. Now we're just going to distribute. I times 5i will give us the 5i squared, and 2 times 6 gives us square root of 12. All right, down here, I times this, square root of 18, will give us I times the square root of 2 times 18 is 36. Okay, let's clean this up some more. You know this I squared is a negative 1, so this is now going to be negative 5 square root of 12 plus I. Now what's the square root of 36? 6. So let's go ahead and do that, and we'll put them in the different order in just a second. All that's left to do is simplify 12. What does 12 break down to? What's their greatest common, or what's a factor of 12 that is a perfect square? 4 times 3. And like I said, I'm going to change that to 6i. All right. What's the square root of 4? 2. So when you pull it out and you multiply it times negative 5, that's going to give you negative 10 onto the square root of 3 plus 6i. It's just that easy. Okay, we're in the home stretch now. This is number 25, and you got negative 4 square root of negative 6 times 7 minus 3 square root of 12. Now all this is fine. Let's get rid of the negative 6 first. So we're going to turn that to I squared times 6, pull the I out. So this is going to convert to negative 4i square root of 6 times 7 minus 3 square root of 12. All right, now we're just going to be distributing, multiplying things that are outside the radical together and things that are inside. Negative 4 times 7 is going to give you negative 28i square root of 6. And negative 4i square root of 6 times negative 3 square root of 12 is going to change to positive 12i square root of 72. So let's clean this up now. There's nothing that will go into the square root of 6. But in 72, a perfect square that will go into that is 36 times 2. Now when you take the square root of 36, that's going to be 6. And then you're going to multiply that times 12. So what we're going to have is negative 28i square root of 6 plus 72i square root of 2. And that's all you're going to be able to do with that because your radicals don't match. Okay, 2 more problems to go. So for this one, the first thing I want to do is get the negative out from the radical by pulling out an I. So this is going to change to 3 minus I square root of 3. And then down here, this is going to change to 2i square root of 3. Now I've just got 2 binomials to multiply together, so I'm going to distribute or FOIL it, whatever you want to call it. 3 times negative 8 is negative 24. And 3 times 2i square root of 3 is going to be plus 6i square root of 3. All right, a negative I times a negative 8 is going to become positive 8i square root of 3. And then negative I times positive 2i going to be a negative 2i squared. Now square root of 3 times square root of 3 is what? Square root of 9, which is what? 3. So let's just go ahead and we'll multiply that in the next step. Okay, come down here. Negative 24 is going to stay like it is. These two can be combined because the radical parts match. So 6i plus 8i is 14i square root of 3. And then here, I squared is -1. 2, a -2 times a -1 makes +2 times 3 makes +6. Now, -24 plus 6 makes -18 plus 14i square root of 3. So you just have to go slowly, matching up what you can and taking care of what you can. One more problem, number 27. Okay, for number 27, we have this binomial squared. So first, let's get rid of the radical, get rid of the negative in the radical. So this is going to be -4. We're just going to pull an I out, and that converts our negative to a positive, +1 squared. Now, when you square a binomial, don't forget, you don't just square each term. You are going to expand this and multiply it times itself, okay? We're ready to fold. -4 times -4 makes +16. I times I is I squared. And square root of 2 times square root of 2 is square root of 4, which is 2. All right. -4i square root of 2 times 1 is just going to be -4i square root of 2. Now let's do this one. 1 times -4i square root of 2 is another -4i square root of 2. And 1 times 1 is 1. Okay. Down here, remember that -1, that I squared is a -1. So 16 times -1 is -16 times 2 is -32. All right, these two combine to become -8i square root of 2. Then you got that +1. One more thing to do. We can combine these two things. -32 plus 1 is -31 minus 8i square root of 2. Okay, so that was a very intense session there. We worked all of the example problems. So if you have any questions, don't hesitate to let me know. I have more practice that I'm sure will help you out. So good job, guys. I'll see y'all later.